So today I'm at Dugard Machine Tools in Hove, and I've come to meet up with Mark Anson, who's been selling sliding head lathes for around about 25 years. He's an absolute fountain of knowledge when it comes to how these machines have changed, how they've evolved, and what benefits they're now offering the UK industry. So sit back, relax, and enjoy this episode.
The MTDCNC podcast, sponsored by Langley Alloys, unique metals for demanding applications, providing first-class performance and an international service.
So, Mark, can you, for the purpose of this this piece, introduce yourself, tell us who you are, and a little bit about your background, I guess, because this is all about sliding head technology.
Mark Anson. I've been in the engineering world since I was 24. Time served apprentice, and now with 25 years in selling sliding head lathes.
Well, how did you get into the sale of sliding head lathes? Were you working one when you came out of your apprenticeship?
No.
Was it quite alien to you at the time?
It was totally alien. So I'd come from a cutting tool background originally.
Right.
So I'd done my apprenticeship in cutting tool manufacturer with a manufacturer based in Tenbury Wells in Worcestershire.
Yeah.
Then joined Stelram Cutting Tools for a couple of years, and then I was interviewed.
Do you think by knowing cutting tools helped you in selling machine tools? Is it a natural transition? Because a lot of machine tool salesmen, in fact me being one of them, I didn't come that route. I came through using a machine, but not actually.
I think what it gave me was a very good customer base.
Yeah.
To start off with, a limited knowledge as you find out when you actually go into machine tool sales as such, but it gave me a good grounding.
And the sliding head lathes, what we're going to try and get out across this whole interview is sliding head technology, where it came from, how it's evolved, what it's capable of now, all through your eyes as someone that's been involved in the game right from the get-go, really. We do a lot. We talk a lot about sliding head technologies these days and how flexible it is, how adaptable, how things have changed. But where did sliding head lathe technology start for you 25 years ago? How capable was it then?
They were really sort of quite limited in what they would do. You had a maximum capacity of 32 millimetre in those days. They tended to be machines that were more not moving offline, so you had less overlap than you would do in today's machines, and certainly a lot less tooling, a lot less capability.
But what were they trying to replace at that time? Was it like in the cam auto days?
Cam sliders and cam autos, and Wickmans as the multis as well.
Because I used to go in a lot of shops, and there was a lot of oil everywhere, and there's a lot of cam machines going, and it's noisy and stuff like that. Was that about 25 years ago when people started to look at replacing that technology with a sliding head? And if so, why?
I think people were trying to do more and more in single operations with less people on a more automated basis.
Yeah.
And because sliding heads were designed to do long, thin parts, they wanted to try and automate that role as well.
So interestingly then, what is the difference between like a cam auto machine and the sliding head lathe when you principally look at the two sort of mechanically how they operate?
Well, really, I mean, sliding heads are designed around feeding the material through a supporting guide bush, and the turning tools coming down in front of, or the tools, whether it be drilling, milling, or turning tools coming down in front of the guide bush, so you're actually machining at the point of maximum support, which enables you to do long, thin turns in one operation.
But how does that differ from a cam auto then?
Well, a cam auto is where the material's feeding out of has a collet chuck. The collet chuck's holding the material, and it's feeding. It's not supported in any way, so you get deflection. So you can only do long, shorter parts.
But both products aimed at volume manufacturing.
Correct.
Essentially. Then,
yes. Yeah.
And I guess industry was very much like that at that stage, was it?
Yeah. I mean, what you tended to find in when I first started, selling sliders, was they were more based around shops that were just sliding head shops, doing multiple turn parts, or they would have sliders and cam autos and Wickmans. So it's volume parts mainly for the automotive sectors. A lot bigger volume than it is today.
Yeah, and now when you look at some of the things that have evolved, what's that journey look like in the last 25 years for you, in terms of where you've been selling machines, how things have changed, and going right back, I guess it's the 1990s really now.
Yeah, I mean it's changed. I think a lot of the businesses seem to be a lot smaller these days. We seem to have a lot more sort of 1 to 10 man businesses where they've been breakaways from the bigger machine shops. And I think what has also happened is that people with fixed head technology have recognised the advantage of sliding head and captured hold of some of that technology.
Some interesting points there, because you've been throughout this last 25 years involved in the sale of sliding head lathes, so you've seen the way companies change as well within our industry.
Yeah.
And an important point there, you say there used to be businesses that had lots of operators, lots of programmers, multiple people that they could lean on, I guess, to run machinery.
Run the machines, yeah.
But you're not seeing that as the case now in the places where you're selling sliding head lathes compared to
what you have today is particularly in the smaller subcontractors, is the owner running he's being part of the team running the machines. What he wants to be able to do is to be able to set that machine up, get it running, and then get on and do something else, whether it's setting another machine or getting on doing invoicing or whatever. So it's giving them that freedom to be able to get on and do other things without having to employ multiple people because they can't get hold of them.
And so whereabouts in this journey as well have we seen significant changes in the machine's capabilities? Because we mentioned cam autos, volume parts, and mainly turn parts, I guess.
Yeah.
But now it's very different because the machines are really capable, which I'm sure you'll touch on in a minute. How have they evolved over the last 25 years?
Really, what they've become is turn mill now, because people no longer want to. Particularly the smaller subcontractors are pushing the machines to the limit. So they want to be able to turn, they want to be able to mill, cross drill, end working. The whole operation. So the demand of the customer has led the machine tool company to develop the machine capability to be able to do what it will do today.
But what are some of the things that have happened in this period of time? Like went from turning to turn mill, then potentially having more tools, then potentially having Y axis and additional axes, and then B axis. What is that sort of over that period of time have these machines had added to them from an automation perspective?
Well, it's bringing in offline capabilities, so the subspindle is not only just picking the part up and working in line, it's then coming offline and working totally independently. So basically bringing the time cycle down by 40-50%. You've got a lot more overlaps going on because it's all about getting it from bar to finished in one operation as quickly as you can.
So on the machines, what enhancements have been added to them from a hardware perspective that are enabling them to do like this kind of bracket part that you talk about? What's on them?
Well, what you've got on there now is not only cross-working abilities, you've got end working. Basically you can attack the part from or the bar, the component from all angles now. So basically you've got everything now that you would have on a fourth axis VMC, but including turning on the machine.
Is there anything now, as we take at where we are today with one of the most sophisticated sliding head lathes that you could supply? What is the restriction? Is it just bar diameter?
It's really bar diameter, yeah. I mean, it's the imagination of the customer, really, I think, is the two limitations.
Let's get on to that point, because that's the interesting part for me about sitting here with you, knowing your history. How hard is it for you, and how much education do you have to offer to end users in order for them to invest in this technology? Are they still well behind the curve on it? Do people still not realise what is available to them?
I think it's people's confidence. People still think of sliding headers as volume turn parts, and it's not until you integrate it into a company, you train them. I mean, at the end of the day, a lot of it is the training and getting people's appreciation of what the full capability of the machine is, rather than just, because quite often a customer will confront you, I want to make this part, whereas what you want to train them in is the full capability of the machine. So it's all about doing the training in a structured way, such that you can impart the knowledge about what the full capability of the machine is, rather than just limited to what they want to do initially.
So are you saying then that you might often be presented with a part and you look at a completely different way of making it to what they are making it at the moment, and they're not, and that's where your sort of expertise and history of education
it's going through and advising, really, because at the end of the day, you've got to listen to what the customer's asking, but equally you've also got to impart the knowledge of the business into moving them forward, because it's like long thin turns are capable on a sliding head, whereas they're not on a fixed head. You've got to sometimes change the thinking of how they make the part, rather than just doing it in the same way on a quicker machine.
But also on the flip side of that, longer term parts, that's probably what the majority of people would associate these machines for.
Correct.
Do you walk around a machine shop then and see, small prismatic pieces, like brackets, like you say?
It's changed completely. I mean, there really is no limit, as long as you can get it out of with us it's a 42mm bar. As long as you can get it out of a 42mm bar, then the sky's the limit, really, I think is the best way of putting it.
And if you can change the way a part's made by using one of these machines, what become the advantages, and what advantages do you see that the customers then come back to you and say, Mark, that changed everything? What will they get from it?
I think the big thing has been that because, let's put it another way, because the amount of skilled people within a business has come drastically down in today's world, because they can't get hold of people, or they want to shrink their business down and get more out of a single machine. It's changed dramatically now, over the years. So now people, if you can show them a solution where they're getting a completely turn milled finished part out in one hit, then it's a winner for you.
But I guess, do the things like to bullet point them, is it things like that one hit machining? Is it a more accurate part? Is it a quicker part? Is it what are the aspects of by doing things in this way?
All of the above, really. I mean, it's I think it's also about getting it from bar to going out the door. And it's really, at the end of the day, a lot of it's people's imagination as to what can actually come off the machine.
What are the challenges people do find with, or what are the challenges you find with getting machinery into places like, and speccing out machines like bar feeds, high pressure coolant, swarf extraction? What are the things that tend to go on these machines now that help achieve the results that we talk about?
I think with the early days of sliding head, it was all about, swarf control was a major problem, and I think in today's machine it's changed terrifically, because you have chip breaking technology on the machines. You've got high pressure coolant. There's so many aids now to help them with that machining process. And once you can get people believing that this is what's possible, then it opens up a completely new world to them to be able to do it from multiple operations, because they no longer have the people any longer so people have a lot of work in progress. You're now moving it to done in one hit and out the door.
And when you look at really some of the major advancements on the machines, you've mentioned one thing to me about more tools and stuff like that, and offline machining. There's a lot more going on in these machines, isn't there? So
yeah.
does that therefore make it much more difficult to operate and to get going? Is it? Do you find people are quite apprehensive about?
Well, people are nervous at first, obviously, because as soon as people are moving into something new, then yes, they are apprehensive. But that's where the support comes from. At the end of the day, that's where the support is very important, to such an extent that and that people know that support as well is continued on the on the end of a phone is terrific. So I think it's guiding them through into the first place to bring that introduce that technology into their business, and then applications take on with training the people to make them believe that what you've said is right.
And when you mentioned about the bracket part,
yeah,
that again most people that are listening or reading or watching would think to themselves, that's not possible on a machine like this, or there's no benefit to me making it on a machine like this. Is there any other applications you can think of that over the period of the last 25 years you'd look at and most people would go, Mark, there's no way that could be done on this machine? You must have encountered loads of
I think one of the major ones was where you've got some of the medical components where they were originally broken down into, because it was the only way that they could be made, they were broken down into multiple sections. And here we are now, able to show them it being done in one hit, because it's being done on a sliding head. And
when you say that, then what you mean, an assembly that might have been 4 different parts?
Correct.
They made it that way because it's the only really way, the most productive way to make the final part.
That was the way that it had always been designed, because of the limitations of the existing machinery.
So using that example, what would have been the limitations of the machine that didn't enable them to make it as one final part that they can now?
Well, you couldn't do long, thin turns mainly, is the, so some of the surgical, the medical instrumentation and that, where we can do long, thin turns, and it being a mill turn part, with holes coming from every direction, limited it as to what it could be done and how it could be achieved.
Yeah. With advancements in the capabilities of the machine and the complexity of the parts that you make, I guess then brings on challenges for machine tool manufacturers, like they need to, maybe different materials need to be cut, maybe machines need to be, slightly heavier or have more power. What are those things that need to come with the continual evolvement of the machine in order to cope with these more challenging parts?
It's more it's mainly the swarf control is the major thing. So it's all about chip braking really, is because one of the problems with long thin turns on a sliding head is swarf tends to wrap around the part and prevent the subspindle being able to come in and pick up the part. So you've got to prevent that wrap around. So it's the technology and where that had been a thing through a traditional sliding head shop of being a natural, they knew of ways to do that. When we're sometimes introducing that into a fixed head environment where they're new to the technology, we've got to produce the technology to be able to break that swarf and prevent it happening in a more simplistic way.
And you mentioned the fixed head machine. So a fixed head machine, I'm thinking maybe a twin spindle, twin turret machine.
Yeah.
Is something that you may be thinking that sliding head lathes are migrating into now, taking market share from, potentially.
It's certainly developed that way over the sort of the 20 odd years that I've been doing this. Yeah.
But one would argue with those types of machines, they are bigger, they are heavier. They do have more power on them, maybe. One, is that the case? And secondly, are sliding head lathes trying to bridge that gap to be able to cope with the same demands that a fixed head machine can, and if so, how?
I think the thing is that the way I've seen it is that at the end of the day, sliding head, the motors on a sliding head are capable of performing the machining operations on that size of bar. And at the end of the day, the construction of the machines, closeness of tooling and things like that, it naturally makes the part a lot faster cycle times. That, along with the way that sliding heads work in being able to do long thin turns and operations, it speeds the whole thing up. And I think once people start seeing what the machines are capable of, the imagination is then the limitations.
And is there a possibility that you go into a machine shop and you see some vertical machining centres, and are you thinking in your mind, I could come back here if they had some vertical machining centres, some straight three axis turning machines? Is there a thought pattern in your mind now which is going, I could be coming back here in a year or so's time, and it could have replaced 2 or 3 of those machines with one sliding head lathe?
Yeah.
Is that something that you have is that where you see as your compelling sales opportunities in those sorts of environments?
It's certainly changed that way over the years, yes. Because people can no longer get the multiple or don't want to take on the multiple skilled operators any longer. They are then trying to find ways of how can I. It's really what mill turns do on the larger turn parts. We're now doing on the sliding head parts, but more effectively. Once it gets down below 42 millimetre, we're doing it far more effectively than you would do on a fixed head lathe.
Yeah, and I mean, we talk about then this 42 mil bar. Could you ever see sliding head lathes going bigger than 42 mil? Because that to me is the break point at the moment, isn't it? And that's where you're not able to win orders when bar diameters go much bigger than that. No. Why is that? And do you think it will ever change?
I think a lot of it is people's confidence. Once even taking them up to 42 millimetre is sometimes a bit of a challenge. But we've done that successfully in some of our machine sites, and I think it's then basically convincing the customer by seeing something happen that they seeing's believing. And if they can see it happening, then they'll take it in, because really at the end of the day, the people nowadays haven't got the time for the multiple operations. So if you can convince them that we can take them from here to here and with less people, then.
But what about this bar diameter argument though? So we've got machines that are capable of 42 mil.
Yeah.
52-inch bar on a sliding head lathe. Do you think it will ever happen?
Yes.
You do, and so in your mind, why is it not happening at the moment? And how big will the opportunities become if and when? And how do you go from? Okay, we say this. People don't often look at 42 mil and think it's too big. So talk to me about your opinion about that 2-inch bar slider.
I think what we've got to achieve is to be able to give people day in day out the confidence that machine will produce the parts that they want. And I think it's working on machine designs and holding the bar, and because at the end of the day you've got a 3 metre bar behind the machine. You've got to be able to control that even if it's bent. Those are the sorts of limitations on it, but I can see it happening. I mean, Hanwha have already done it with 42 millimetre bar.
But are they? So what are the main reasons at the moment there's not a 2-inch machine? Do you think is it because of the it is purely down to the size of the bar, the weight of the bar, the move in the bar backwards and forwards?
Yes,
is that the reason?
I think it's restrictions and people's belief that it will happen. So it's getting the machine rigid enough to be able to control that bar.
Yeah. Would it slow things down?
Slow
the machine down in general? Would you need to slow it down?
You would need
do you find that the bigger the bar diameter, things naturally are slower?
Yeah, I mean, we'd have to slow the RPM and the yes, certainly.
Yeah.
I think even getting people to believe about putting 42 mil bar on a sliding head has been, but seeing is believing, and I think once we get a machine into an application and the people believe it, then they'll use it more and more.
And if there was a 52 mil bar machine, what does that open up as opportunities for sliding head lathe manufacturers compared to where it is now? How many more machines are you likely to sell? What is that gap in the market that you're not getting at the moment?
I think it sort of takes in another 30% of the more sales on it. I'd say, because you're talking about, there's a lot of the fixed heads that are working on, there's still a lot of fixed heads around that size bar.
Yeah. And barriers to entry with technology. So we've talked about how the journey, how you've seen the improvements in the technology, the complexity of parts you can now make, the chip control you talk about, the offline machining, and all of these things that make parts faster, quicker, more productive, and more complex parts in one hit. Does that bring challenges with how you set the machine, the length of time it takes to set the machine? You talk about tools being quite close together because there's more of them. What are the things that people might fear when they look at how what they've got in there now? Because it's a much different animal to what it was 25 years ago.
I think it's changed dramatically, but I think then again, a lot of the machine technology's changed out there, and the capability of fixed head machines has changed dramatically as well. So I think once you can get people around the site, and it's the facts, and it's through training, showing them, I don't know, on a existing customer's site as to what's capable, talking to other customers as to what's been achieved. But
do you have to show them how to change? Can you show them? I mean, it's speed of set, because I guess one of the points I'm trying to make here is that you talk about, and we mentioned that years and years ago it was about volume manufacture, it's about high volumes of parts. Now it's not.
It's all about speed of setup.
Okay, so this is one area that's important. What do we find on machines these days that is a lot faster to set to get to your goals of changing parts as well as doing volumes?
I think the tooling on the machines has changed quite dramatically as well. So there's a lot more tooling that's been designed about quick changeovers. I think the tooling manufacturers have recognised as to what the demands of the sliding head customers are, and design the tooling and the applications around that.
And does the same apply to the collets and to the to the guide bush and all this sort of thing too?
I think the collets and guide bushes have tended to stay with what's known and what's proven. It's mainly been around the quick exchange and quick change round of tooling within the machine, because basically if that machine's down or a tool needs changing, then you're losing money, and one thing that the people haven't got is time or
And would you say that's the fundamental difference then between the fact that now sliding head lathe manufacturers say these machines aren't just for high volumes,
no,
they're for lower volumes? The two things in my mind that have changed significantly there are the tooling that you talk about, but also the quick element of getting a program in for a new part. I think, are they the two areas?
I think the other thing that a lot of people are, I mean, even though you still get a lot of the smaller subcontractors wanting to do the programming on the machine, I think there's also a lot more programming done off the machine, ready and proven before it actually goes on. So literally all you've got to do then is to single block through and run the program through, but you've got the confidence that is has already worked. And
how often are you going into places where they're doing 100 off, 200 off, 50 off, and you're still selling them sliding head technology? Can you just maybe best describe what that market looks like these days and how common it is for you to be?
I've seen people just even where they're making simple Inconel dowels, for instance. So and they're making them in sort of 5 and 10s off, where they're literally making a dowel of one diameter and a certain length, changing the program on the machine and then moving on to another one and bagging them up in a Ziploc bag as he's gone along, and getting a terrific hourly rate on the basis of it.
And what's enabling him to get that terrific hourly rate? Because the change from one size or one part to the other is fast.
It's fast, yes, exactly.
Yeah.
So it's fast changeover. But it's also about the ability to be able to get it all off in one hit, you know. So.
And do people have to worry about? Let's talk about longer runs. Do people have to worry about unmanned running overnight? Do they? You know, what are the things you have to take into account? Is it chip breaking software?
I think,
is it unique cutting oils, your coolants? Is it slowing things down a little bit? What's the overnight policy?
I've always said to people to give them the confidence. Then, you know, whatever you can do during the day, you take, say, 70-80% of it, and let the machine run for that process during the evening. So in other words, if the swarf control and tool life is giving you 100% during the day, then knock it down to sort of 70-80% during the evening.
Yeah.
Nowadays, it doesn't necessarily mean slowing the process down at all. It just means limiting the number of parts that you because cutting tools these days tend to be a lot more consistent in the tool life that they'll give. So if you've got good, the damaging thing can sometimes, or would have been, the swarf control. So if you've got that swarf control built in, under control,
yeah.
I can't think of a better way of putting it,
Yeah.
but if you've got that process under control and it's a nice stable process, then you can let it run. So that then opens up a load more time during the off shifts or walk away time during the day.
Is there any businesses that you've worked with that you think sliding head technology has saved their company?
I think the thing that's happened over the years is that not only saving the company, but where they've not been able to get hold of the skills these days, it's saved them from the point of view that they can still produce the parts that they need without being able to get hold of the people that they had needed. That's what's changed dramatically.
And do you see that as a trend that's I guess is going to carry on?
Oh yeah. I mean, it's. I think where skilled people are harder and harder to get, and not all of the younger ones want to come in engineering, then people are having to manage with fewer and fewer people.
What about the control system? Again, we talk about the ability of the machine being able to make more complicated parts. Therefore, that's got to be programmed.
Yeah.
So, is it easy to do? Are people still able to program the offline part, the different axes on the machine, all at the control, and be ensured that
I think
they're going to balance it, because balancing it is everything.
Yeah, I think where a lot of it is down to the training that we have to do to make sure that people fully understand all the different processes and how to achieve them, and then the continued support as well from there, people knowing that they can pick up a phone.
But is it set out when you look at the control system and you sit in a classroom or you're at the machine? Let's say you've got two spindles, you've got two working areas essentially that maybe cross and work, in conjunction with each other. How do you look at doing that? I mean, do you program one area, then the other area, and then the machine works out?
Well, you're basically splitting the job into half. What's done on the front end, head one, to what's done on head two, and that's all part of the training that we would have to do to how to split that up. And
then making the parts so that it's balanced. So if it's taking 2 minutes on the front, the back is machining the majority.
Well, you want it basically sort of 60-40, because you've got to be able to split the part out as well at the end. So, yeah.
And that's how you work it then. You look at a 60-40 ratio.
Yeah.
Does the machine say to you, well, that's 30% and that's 70?
No. Do
you have to use
your
own?
We have to import that knowledge to get there. But I think with the programming software now that's available, where you can give people the confidence that I can build the program up with importing blocks of code, and then I'm just putting in the data into to complete the coding. It's helping, so that's already pre-written. It's helping people that they can see it simulated, so it'll produce a drawing of what you've programmed. So you can see that radiuses are going in the right way, the grooves look in the right place. It then gives you the confidence to then feed it into the machine. And so with a lot of the newer users, we give them the confidence that we're doing it on a PC first of all, whereas going back 20 odd years ago, it would all have been done on the machine.
And is it, just to sort of summarise then, in your mind, after this 25 years in selling and supported sliding head lathe technology, are you in a much better place now being selling this equipment because your market's much broader, your opportunities are greater? Is that really how you would summarise where
I think it's a lot of it is people's belief at the end of the day, because what tends to happen with the engineering world is people follow with what they've previously had success with. So introducing new technology, and people say, well, there's a lot of sliding heads out there these days, but we're still introducing new, the technology, into new businesses, and it's been showing people to start off with, and that can be taking them into an existing customer and really growing that belief, and then the world's the limit then, really, so from then on.
And then when you've sold machines with real capability on them, like a complex machine with lots of axes, how much has it changed some people's businesses? What would they say now? Do they come back to you and say, Mark, my God, before I had this machine, I was nowhere near as achieving what have you got some
I think what it's done is it's opened up the engineering world is no longer just an 8-hour shift. It's however long you want to make it. It's opened up that belief in that with fewer people, I can produce all of the parts that my customers are demanding.
So, in summary, then, for people that are interested in this, what are the limits? What should we be finding? What's the message you're trying to get across?
Well, I think the thing I'd like to get across really is that certainly over the years, what I've seen is massive change in the capability of the machines, and I think with the machines that are available today, it's people's imagination that really is the limitation, and confidence. And I think it's all, I've seen where I've moved now from just round parts to now doing prismatic parts on sliding head, and I think one of the drivers of that has been the limitation of staff, and that you haven't got multiple people to do all these multiple operations. So if I can get it all off in one hit, that's the real key.
And I guess you're in a controlled environment because you've got one machine that's capable of doing all the operations.
So tolerances and things like that, you can hold a lot better tolerances on the part, because you're doing it all in one holding. You've got no movement, or inaccuracies due to fixturization or anything. You're doing it all in one go. And the material that somebody might be watching or listening to this and thinking to themselves, yeah, well, I have got a part. It's less than the 42mm bar that we talk about, but it's made out of Inconel. It's quite challenging material. I think
it's got a lot of features on it, angled holes, threads, all these things. They might look at it and go, my best way of making it is on that machine, then fixtured onto that machine. Are they thinking wrong?
I think talk to us is the answer, because I think the capability of the machines now, and at the end of the day, sliding heads hold the material extremely rigidly. The power and the strength of the machine is what you need for the materials. And I mean, over the years, I've seen imagination's really the limitation, I think, with the machine. It's so talk to us when you have a part that give us a challenge.
Thank you for listening to this episode of the MTDCNC podcast, sponsored by Langley Alloys, specialists in a wide range of exotic materials for any application for all your engineering needs.